and running. So what we were working on was doing a join on our sales list. I'm sorry, on our sales rep in sales list. We're inserting the rows into sales department, including the columns employee ID, total sales, region, and then we're going to include that sales rep, which returns our 2 rows. Next, we're going to do our inner join, which is going to return a first name, last name, and then we want the total sales. So this is kind of showcasing how joins will work and why the employee ID primary keys are important in making sure that that relationship exists. When we do our cursor.fetchAll, after using the inner join, we return our 2 salespeople. So here we are going to go ahead and create our IT department. The skills will contain several different values. So once again, we're going to create an array. We have the int primary key, skills is the array, and we're going to say if he's remote or not, which is a bool. And once again, we're going to get the column info, make sure that those columns were created, and then insert the rows. Now, in order to query arrays, we have to use this syntax here. It's select all from IT department where the so this is going to be the object that we're interested in Python. So where Python equals any skills. So it's searching are any of the items in skills equal to Python? When we return that, it returns our favorite IT guy, Mr. Tom Harper. So now we're going to create a customers table. We're going to go ahead and do these same steps. We have a foreign key here, which is going to reference the sales department employee ID, so that that relationship exists between the salesman and the customer which they sold to. And it's going to be the same process here, guys. We're creating our rows. We're doing a for loop, which is inserting those rows. And then we're going to return the values, make sure that they were added correctly. Next, we're going to create a sales table. We have our serial, which is going to be the primary key. We have the customer ID, which references the customer ID in customers. And then we have a purchase total. We have total items. The salesman ID, which is going to be a foreign key that references the sales department employee ID. And finally, we have an array, which is the description of the sale. You'll see later that these arrays are really going to cause us a headache. So just keep that in mind. And once again, we're going through the same steps. We create the columns, we create our dummy data, and then we insert them into the table. We call our getColumnInfo function, which returns the table information. Next, we do our select statement, and that's going to make sure that those rows were inserted properly. So, time to showcase how to do some calculations within SQL. We're going to do cursor.execute, and we're going to select we're going to round the average purchase total to 2 decimals from the sales table. And when we do our fetch all, it returns a decimal rounded to 2 places. So now we're going to query all purchase descriptions sold, the salesman's first and last name associated with the purchase, and the region from which they work. This will require 2 joins. So here we have select sales.description, sales.total items, sales department.region, employee.first name, employee.last name from sales. Inner join sales department on sales.salesman ID equals salesdepartment.employee ID, and inner join employee on salesdepartment.employee ID is equal to employee.employee ID. And then when we fetch all, we can see that we have the item description, the amount of items in that order, the region which the salesperson worked, and their name. So now we're going to create an inventory table. Same steps. We have our serial primary key, a varchar, a bool, and an int. Insert the columns. It looks like here we forgot to add our wholesale price and retail price columns in the inventory. Luckily, our function can easily update the table. So we're going to go ahead and we're going to add those in after the fact. Here I was looking for a creative way that I could extract this information to input it here, but because this expects a string, it would have taken a little bit too complex of code for this purpose, but it is possible. So anyways, we have our dummy inventory, and then we're going to insert the rows, and finally we fetch them all. So now we're going to talk about normal form. Normalization is the process of minimizing redundancy from a relation or set of relations. Redundancy in a relation may cause insertion, deletion, and updation anomalies, so it helps to minimize redundancy in relations. Normal forms are used to eliminate or reduce redundancy in database tables. First normal form. If a relation contains composite or multi-valued attribute, it violates first normal form, or a relation is in first normal form if it does not contain any composite or multi-valued attributes. A relation is in normal form if every attribute in that relation is single-valued attribute. So arrays versus relations versus tuples and first normal form. Arrays bear some relationship to relations and tuples, but all three are different in significant ways, which means they are best at solving problems. Different problems. Like tuples, arrays are ordered. However, unlike tuples, every array element must have the same data type. This means that arrays of text can represent tuples of any type. Unlike tuples, arrays do not have a fixed number of elements. Elements can be added without disturbing the basic type. Like arrays, relations are basically rectangular and open-ended. Items can be added or removed from the end. However, arrays are ordered, relations are not. This means that an array value is a domain, while a relation value is a set or bag of domains, depending on constraints. All data types in an array must be identical. Relations do not have this restriction. What this means, basically, is that the mere use of an array in a column of a table does not necessarily violate the first normal form, if the array is used in a way that suggests that ordinality matters. For example, we could store matrices from matrix arithmetic as numeric arrays. We could store some problems that are transformed into numeric matrices into the database as well. For example, simultaneous linear equations, and these would not necessarily violate first normal form. So if you remember back, we did use some arrays, and unfortunately, they did not have any ordinality. They were just haphazardly listed in there as the items that were sold. So in order to get our database into first normal form, we have to go through and break up all of these arrays. So in order to do so, I have to alter the table, drop the column for both the description and the total items, because total items was counting how many values was contained in that array. So we're going to get column info sales. We see that they were dropped. We insert columns. We're going to insert a new one called item, so it's just going to contain one, the item description or the item name. So we can see that that was added here. When we do a select statement, we see that there's these none values. So it has removed those descriptions and replaced them with none. So now we're going to have to insert those, or I'm sorry, we're going to have to update those rows in order to contain the actual item that was sold. So we're going to update the sales table in the column that says item. we're going to insert GPU where the order ID equals 1. And once again, we're going to update the row of the table sales. In the column purchase total, we're going to insert 200 where order ID equals 1. Finally, because there was 3 purchases, we have to add even more. So we're inserting our rows, we add that monitor, we add another one, and finally, this is going to be the result. After all of that, we have to basically tear our table apart, restructure it. This is what it eventually will look like. We can see that each one is uniquely identified. This is the customer ID, the salesman ID, and then this is the item that they purchased. So we'll also have to do the same thing for the IT department. And this one gets a little tricky. So the IT department primary key right now is that employee ID. We only have the one guy, Tom, in there. But if we restructure this array so that it has, if we break that up into 3 different rows, it's going to violate the constraint of the primary key, which forces it to be a unique value. So in order to handle this, we're going to drop the constraint. Drop constraint IT department underscore primary key. So that's going to get rid of that constraint on that employee ID. Next, we're going to add a foreign key constraint into it. So what that's going to do is it's just going to make sure that the employee ID actually does exist. And then we're going to break it up. When we do our select all statement after breaking it up, now we have 3, 3, 3, which is all Tom, but each row is unique in the fact that they have different programming languages. So second normal form, you must have reached first normal form, and all columns in the table rely on the primary key. Well, if we take a look here by calling getColumnInfo, you can see that our columns actually, our tables actually do have a reliance on their primary keys. For example, the sales department region does depend on employee ID. The purchase total does depend on the order ID, and so on. If you were to go through all of these, you would find that that is the case. So third normal form, must not be transitive dependencies. So that means that in order to get from, say, table A, in order to get to table C, you must not have to go through B. So if you remember when we did the double join, that is a case of a transitive dependency. So unfortunately, our database does not reach third normal form, and without some further restructuring, we will never be able to achieve that with this database. So next week, I'm going to start going into NoSQL. We're going to break down this database and we're going to put it into a NoSQL form. And I personally believe that for this use case, NoSQL will be the better solution of the two. Relational databases are great for reads, but not for writes. And this is a store, so there will be lots of information being added regularly. Customer orders, we're going to have lots of changes and writes and updates and so on. So this will be a better case for a NoSQL database. And next week we'll be able to see that. So once again, thank you for taking the time to watch my welcome webinar. And I've experienced many technical difficulties. I hope that by next week I have this all figured out. So actually, this was my second recording. The part 2 was not supposed to exist. I had finished the hour and somehow YouTube hacked off the last 20 minutes, so I had to redo it. And so I may have to seek out another option as far as recording these webinars for everyone. unless I can figure out a concrete way in which YouTube will definitely save this information, because I want to make sure that even those students that aren't able to attend at the scheduled time do have access to this information. So once again, I hope you guys go to the GitHub, you download the notebook, you get to play around with this code, see the effectiveness of those functions. Be careful with them though. You must make sure that the data that you input into the functions are going to be right the first time, because I had a few instances where I actually had to drop the database altogether and start from scratch because of repeat columns and such things like that. So this, when working with databases, you must be very careful. So with that said, once again, thank you for watching the video, and I hope to see you guys soon. Feel free to reach out to me on Slack, and we can, if you have any questions about any of this code, we can discuss it in Slack, or we can schedule that one-on-one, and I can try and break things down for you. Anyways, I hope you enjoy your upcoming week of the new data engineering course, and good luck, and see you soon.